minimize some of this stuff so it's not in my way. And then I'm going to start with my blank. You guys can't see anything, right? I changed the display the other day. Hang on, sorry. I'm recording this, so this is going to, anybody that's watching this is just going to be like, what is happening? Arrangement. Why? Oh, wait, no, it's not my issue. I have to change the input.
Right, well, James figures that out, which he now
should be figured. Yeah, should be good. There we go. I'll about the workshop.
Yeah.
I'll do it. So, yeah, thanks for coming out. I'm super excited for this workshop. I think Bash and command line stuff is like some of the most important stuff that you need to do, because it integrates with basically all of the other stuff that we've talked about. If you're dealing with sequence data in any kind of way, if you're dealing with many files on your computer, if you just want a really powerful way to operate your computer instead of using like the GUIs that come with the computer, using Bash or some shell and the command line is sort of the way to do it. And it's also an essential skill for anybody that wants to work on a server or computer cluster or like Amazon Web Services or like any sort of cloud-based or cluster-based service. You have to be able to program using on the command line because you don't have GUIs and browsers or none of this stuff when you're working in that space. So today is really just like a really simple introduction to the command line and programming in the shell. You never have to have looked at a terminal or anything to be able to do some of this stuff. So we're starting from sort of my blank desktop here. So we're just going to go ahead and open up our terminal. So if you're on a Windows machine, that's going to be git bash. If you're on a Mac, you just open your terminal. You could do that by going to Applications, Utilities, Terminal, or you could open up your Spotlight in the corner here, or press Command Space and just open up Terminal. And I'm going to make that full screen, make the text bigger. And your terminal might look a little bit different than mine. If you're on a Mac, the default is going to be just like a white terminal window. Mine is customized and stuff, and I'll talk later at the end about how you can make your terminal look as pretty as you would like it to. But we'll get to that at the end. So I'm going to go ahead and just get started. Basically, this is the kind of interface you're going to be interacting with. And
1 second, the live stream is still green.
What does that mean?
Make sure that the screen share is on. The Hangouts thing. Sorry, everyone. Yeah. So click on the green icon on the top left.
Green icon.
Top left.
Top left. Oh. Well then.
Press stop at the top and then try that again.
Technical difficulties. Yeah.
Okay, I see your screen now. Yeah.
So now we're good.
Give me 1 second because there's a bit of delay here. Oh, and now it's green again. Why?
Present to everyone. What does that do?
1 second. Wait, it's okay. It seems you're good now. I'm going to give it 2 more seconds. It's a bit of lag. It's weird hearing myself from 10 seconds ago. Yeah, you're fine now.
Okay. So anyways, this is now if people watch the video, they'll be able to see that this is what your terminal looks like. We're going to just like jump right in and start running commands and seeing the kind of stuff that we could do. So there's a bunch of different commands that come sort of distributed with Bash that are sort of helpful to know. I'm going to walk through some of the simple ones, some of the ones that you guys sort of need to be aware of. So the first thing, when you open up your terminal, the first thing you might want to know is like, which directory are you in, right? Like where on your computer are you located? So thankfully we could use the command print working directory, pwd. And you could just enter that and it'll tell you which directory you're in. So the cool thing about the shell is most of the commands have very reasonable names, right? They're shorthands or abbreviations, often like take the first 2 consonants of what the command does, smash them together, and that becomes the command, or they just become like little abbreviations. So for example, by default, you're probably in your home directory, which might be like users / your name, or whatever. And you might want to know what files are in that directory, right? Maybe you just want to see what files are there. So you could use the ls command for list. So when you press ls, you should see literally a list of all of the files in that directory. Did that work for everybody? Yeah. And mine are color-coded. Like I have folders that are color-coded blue and then files are white. And again, I'll talk a little bit about how to do that later on. It turns out that the computer also has a bunch of like hidden files that you never see when you open up like your My Documents or your Finder window. And these hidden files could be really important for different programs. A lot of like configuration files and stuff are stored as hidden files that you never see. But in the command line, for example, you could see those files if you wanted to. And you could do that by passing what are called flags to the command. So ls is the command. It's the list command that allows us to see all of the files. But when you put ls space, you could pass a bunch of optional arguments to the ls command that tell ls how to behave. It configures the behavior of ls. So for example, if we wanted to see all of the files in the directory, including hidden files, you could pass the a flag. So flags are denoted by putting a hyphen before them. So this is an optional argument that you could pass to the ls command. And if you press enter on that, you'll notice there's probably a lot more files now. And all of the hidden files are preceded by periods. Do folks see this on their end? So these are all hidden files that by and large you'll never have to modify, but in very specific cases you might need access to them, and this is how you would get there. You could also, if you want to, pass additional flags. So for example, you could press type in clear if you want to clear the workspace, because otherwise it gets a little harder and harder to read as it gets sort of lower down on the screen. So we'll pass some additional flags to the ls command. So we'll still pass the all command, but then we'll add another flag, l. L provides additional details on all of the files. So ls with the al flags will print it a little bit differently. But now you see the output for every file, you get a bunch of different information. So all the way on the left here, you have the read and write permissions of the file. So who is able to read the file, who's able to write to the file. You have who created it, and then you have other information like the size of the file in bytes, the date that it was created, all of these different key pieces of information about each of the files. Which, for example, if you were in a GUI, you would like right click on it and then go to like file properties or info or something, and it would display most of this for you. This is just a way of accessing that information from the command line. I'm gonna clear again. And so again, you could pass multiple flags. So A, L, H, S. I'll explain what each of these is. So A, we already saw, will display all of the files, including hidden files in the directory. L will provide all of those details. H provides the file sizes in human readable format. So if you have really large files, you don't want to have to see the file size in bytes and then like divide by 1,000,000 to figure out how many gigabytes it is. This will give you the file size in gigabytes, or like in a way that you could understand. And then S, capital S, is sort. So it's going to sort the files by size. So you could pass all of those flags. The output looks the same, but now you could see that they're sorted, right? So the smallest, or so one of the files up here, like they're not, the hidden files are not coming first anymore, right? So they're all sorted by size. In this case, by the largest files first. So the 3 megabyte file here, plant phenology.
Can you sort by other things? Lost modifier or whatever?
Yeah, you can. And I'm going to point that out right now. If you want to know for any given command that you might want to run, if you want to know like which options you can pass to it, like for example, if you want to sort by something other than file size, you could ask for the manual for that command. So manual intuitively is the man command. And then the command that you want to know the information of, so ls. So if you type in man ls, it'll print out onto your terminal all of the information about ls, what it does, what all of the different flags are. And you could scroll through this either with your trackpad or using your arrow keys, for example. And then you could sort of just look through here if there's a way to sort by date modified. I don't know offhand if there is, but you could probably
It's
dash T. There you go. So the T flag will sort by time modified right here at the top. So there is a flag for that. Cool?
Yes.
Yeah, you look blown away.
Yeah.
I'm liking it. I'm liking it.
Crash was my largest file. So I was laughing at myself. Crash.
Key info here in the when things show up in sort of a terminal window like this and you want to get out of it, you just hit Q for quit. And it'll just bring you right back to your terminal command prompt.
So you mentioned, when it out, git bash doesn't have the command, so you have to add -- help to the end.
Okay, so that'll also work on a Mac, so you can go ahead and do that. You could do ls --help. So,
I don't think it'll work on a Mac.
No.
it does for some
It
commands.
does for some, but not the base one.
Yeah. Okay, fair enough. But some programs that you download, for example, and want to use at the command line, you could often do --help and it'll tell you something about it. Cool. So that's just a basic introduction to like the way that the syntax works for commands. It's always the command and then optional arguments and flags to that command. And those arguments, for example, might be files, as we'll see in a bit. They might be directories, or they might be flags that tell the command to behave in a different way. So we're going to move straight into working with directories. So the first thing we want to do is we're going to navigate to the directory that you guys downloaded from Dropbox. So if you put that in your home directory, you should see it when you list the files in your home directory. But it's possible that you didn't put it in your home directory, right? You might have put it on your desktop, for example. So now we have to navigate to our desktop through terminal. So the way that we change directories in terminal is by using the cd command for change directories. And you should actually, you could change into any of the directories that you see in your current working directory. So for example, if you're in your home directory, you should see desktop, right? So you should be able to just cd and then type desktop. And I'm going to give you a really helpful tip here. You don't have to type the whole word, right? Bash will recognize the word and use tab completion to complete it if that file exists in the current working directory. So I type desk, right? And then I'm going to hit tab and it auto completes to desktop because desk is part of desktop and desktop is in the current directory. So the shell is smart enough to know that that's what I'm looking for. If you have files with redundant names, for example, if I had a file called desk file, it would only autocomplete up to the point where those words are the same, and then you would have to type another character that differentiates them, and then you could tab complete it. So you just kind of have to know what directory you're in and what the files look like a little bit.
You can also hit tab twice if it's not like completing the thing, it'll list out all the possible options. So if you were to type in CD capital D and hit tab twice, it'll list out desktop, documents, downloads,
like that.
So like make one of these.
Yeah. I'll just give you a few helpful commands. So the first, cd tilde. I'll give you a minute to find that character on your keyboard because it's not very often that we see tildes. So it's the squiggly line that's often used like for approximately, for example. So this is shorthand for change to my home directory. And you could do this from anywhere in your computer. You could be, 10 directories deep somewhere in your project folders and your documents, whatever. And then you type in cd tilde and it automatically brings you back to your home directory, which is really helpful. Another one, cd double dot, goes back one directory. So for example, if you guys don't have to do this, but if I print my directory and I'm in users, James Santangelo, if I was to do cd double dot, I'll go back one directory so that now I'm just in users. So I just sort of went one directory previous in the directory chain or the directory structure. So I'm going to cd back to James. Okay, so for me, for example, I put the Git demo folder on my desktop, so I now have to go to that folder. You don't have to like cd to one directory and then to the other. You could provide many directories. So for example, I could cd desktop and then immediately start typing the name of, I don't remember what I called it. I have a lot of stuff on my desktop. What's it called? Perfect. So CD desktop intro bash demo. Yeah, so I could just type that in, tab complete it, and then now I could just go directly to that folder. Are you there?
Oh, I didn't. Do I need to do
Yeah, yeah. You could zip it. You could unzip it from the terminal.
How do I do that?
G unzip?
Unzip.
Is it just unzip?
I think it's just unzip. G unzip is for GZ.
GZ files, yeah.
If you just type in unzip and then the name of that file, it'll do it for you.
No.
I think
You could do it the same way. You could unzip desktop intro whatever, and it'll just unzip.
yeah.
But it'll unzip it into that directory. It'll unzip it into desktop. Did it work?
Did you give it the full tab or not?
It's coming. So yours. So
Oh, no, wait.
I'm sorry, type it out without the zip. Type out CD desktop. Yeah, because now there's a folder for your bash demo.
so
And
is
there's-
everybody else in the folder?
No. I'm the same issue. This is not really.
Oh, it's not unzipped.
I just
Hang
zipped it.
on.
That's like right here.
So you should be able to navigate to it.
I wonder if unzip when it's in this directory. Yeah, just
No buoys.
Let's intro the bash here.
So it's on your desktop?
No,
Yeah.
it's not. So it's head to your desktop with CD. CD desktop.
So we're on the desktop. So
Yeah.
intro
Just
bash
enter.
demo right there.
Oh, how did you do, wait, how did you make it go to that, I thought it was on desktop already, right? And I typed in CD.
So you were in your desktop. So all you had to do was move into intro bash demo. You didn't have to move into
That's what I
desktop.
messed up. Okay,
Yeah.
got it.
So everything is relative to your current directory, right? So if you're on desktop, you don't have to move into desktop, then into.
Got it. Thank you.
Yeah. And then your terminal might actually tell you which directory you're in right there on the command prompt. So once we're in there, we're going to do some. You could do an ls to list all of the files, and you'll see there's a bunch of files that I included in the folder by default. And so these are files that we're going to use, for example. The first thing we're going to do is actually learn how to create directories. And we could do this with the make directory command, which is simplified to mk for make, and then dir, directory. And we're going to create a directory that we're going to call text files. And so all we have to do is use the make directory command and just pass the argument, which is the name of the directory that we want to create. So text dash files. And just press enter on that. And then we'll do an ls. We'll just list the contents again. And we see that now we have this new directory, text files. I want to take a minute here to just talk about naming files and directories. So you'll notice that none of the files or directories here have spaces in them. When you create files on your computer in Finder or My Documents or Word, it's common practice to put like, you know, my space manuscript or whatever. But if you're working with files from the terminal, you should never include spaces in your file names. And the reason is because spaces in Bash are used to separate commands from arguments and flags. And so if you include spaces in your file names or directories, the command prompt will interpret that as separating arguments or commands or flags, and it'll just throw an error. And so it's best practice to, if you know you're going to be working with some files or directories from the command line, always separate them with like dashes or underscores and stuff like that, so that you don't run into that problem. I've gotten to the point where I just start naming everything. I just make sure I don't have spaces in any names. And then I don't even have to worry about whether I'm going to use it from the command line. But it's important to know. So in a similar way, we could use the remove directory to remove one. So let's use the rmdir, remove directory, and let's try to remove the folder to delete folder. I gave these folders intuitive names, so hopefully. So run that command and see what happens. Exactly. So rmdir by default, so the remove directory command by default will not remove a directory if it has files in it. So that's good, right? Like one of the things that scares people about the terminal is that they're afraid they're going to like screw up their computer in some way, like cause like irreplaceable damage to their computers. And like you can do that. You have to be pretty careless to do that, to be honest. It's not as scary as it seems. But if we know for sure that we wanted to delete this folder, for example, let's use the ls command to list the files in that directory. Let's see what's in there. Why is it not empty? So you can do that similar to how ls will list all the files in the current working directory. You could actually just pass a folder name to the ls command, and it'll just list the files in that directory. And so there's a single file in there. It's called file deleted with folder. So clearly we don't need that file. It's not useful to us. So we're going to force delete this folder and all of its contents. So the way that we do that, we don't actually use the rmdir command. We don't use remove directory. We do it just with remove. So rm, as we'll see in a minute, remove could be used to get rid of individual files, but you could pass two flags to it. So remember, flags are optional arguments that you could pass to it. So the first one is r, and the second one is force. So R stands for recursive, which means you could use it on a folder and it's going to go through all folders and files that are subdirectories of that folder and recursively remove all of them. So recursive is necessary for removing folders. Force, which is the F flag, is basically like, I'm sure I want to do this. Don't warn me before doing it. So this is like a hard removal. And if you do that, you could pass to it the name of the folder you want to remove. Yep.
Can you use just one of those flags? Because RMR works fine. I just did.
Yeah. So it depends on your permissions. If the permissions of the, remember how when you list all of the files and stuff, you could see the permissions. If you have read and write access as an admin, for example, to that directory, you don't have to pass the F flag. If you didn't have read and write permissions to it, it would ask for administrator privileges and you would have to type in the password and stuff, and then you'd be able to do it. But in your case, because like you own the laptop, you have all of these permissions and stuff, you can just do it.
Can I mention one other flag actually?
Yep.
The dash V flag, which we can use in a lot of commands we'll talk about today. You don't have to use it here, but adding dash V to a command like RM will spit out, like it'll actually print out what it deleted, which is sometimes useful for deleting a bunch.
Yeah.
You don't have to have it there. It's helpful to know about.
Yeah, I'll add it anyways. It stands for verbose. So like, tell me what you're doing, basically, is what you're asking the command. So if we do that, you'll see it deleted, folder to delete with that text file or this file in the folder to delete, and then the actual folder. And so now if you do an ls, that folder's gone. And just a word of caution here. The folder is not in your trash. It's gone. It is shredded, vaporized. You're not getting it back. So be incredibly certain that you want to remove this file and its folder contents. And there are other practices that you could use to make it so that if you do accidentally remove stuff, you could get them back. Git is really good for that. So show up to the Git lesson. So yeah, we'll worry about the rest in a bit. We could start working with some of these files that we created. So the first thing we're going to do is just look at how we could sort of visualize files from the command line, right? We have like these text files like to delete.txt, animals.txt. You could ls the scripts folder, for example, to see what's there. You'll notice there's a couple folders like hello world.py, print numbers sh, some useful script.py. There's all of these scripts that we added there. So let's say, for example, we wanted to look at the hello world.py script, right? So we could do that. The hello world.py script is in the scripts folder. So you could move into the scripts folder and then view it, or you could actually just view it right from here by passing the full path to that file. So the command we're going to use is cat. which I think stands for concatenate. Is that right? It's concatenate. So you could actually use it to combine many files to one in like the true sense of concatenate, or you could just pass it a single file and it'll actually just print all of its contents to your terminal. So using the cat command, let's pass the full path to the hello world script. So we know it's in the scripts folder and then hello world. And then if you press enter, you see that the folder contains only a single line, which is Python saying print hello world. So the reason I'm doing this, one, now you know how to look at files, but also just to convince you that Python scripts, R scripts, Bash scripts, they're just text files that the computer knows how to execute if you have the proper commands installed, and you could just run these scripts from the command line. And we're going to talk about that in a bit on how to actually do that. But there's nothing special about a Python script or a Bash script or an R script. They're just text files with instructions on how to do certain things. So we could also try to look at the animals.txt file that we have here. So let's use cat on animals.txt and see what comes up. So a bunch of stuff, right? So this is a huge text file that just has a bunch of animals. You could scroll back up through your terminal window to see all of the different animals that are listed in there. But again, cat just prints all of the contents of the file to your command line. But maybe you want something that's a little more efficient, something that allows you to sort of look at the file a little more interactively. You don't just want to spew its contents to the terminal. So you could do that with this command called less. I'm going to clear this so that you guys can see that. So less animals.txt. So you see now you don't see the bottom of the file because it didn't just print everything to the screen. You see the top of the file, right? So we see the animals that start with A. It's a little cut off there, but you guys get the sense. And so the cool thing about less is that it's what's called a pager, in that it's only loading a single page at a time on your screen. So whatever could show up on the screen is what's being loaded. So it's not holding the whole file into the computer's memory. It's really only showing you what you see on your screen. And as you scroll down, it progressively loads the bits that you're trying to view. So it doesn't have the whole file loaded at once. It's only loading what you see, which is really helpful if you have incredibly large files, like whole genome sequence files that you want to look at, for example. You could do that with less, and it's not going to crash your computer. If you did that with cat, it would just keep printing, just spewing the whole genome sequence out. And depending on the size of that, it might be pretty large, which is pretty inefficient. I've done it.
When we opened man pages earlier, like a /help pages on Git Bash, it actually opens it in less. So what you saw earlier when opening a new page, that was literally just an instance of less. So we're using the same thing that Bash would for that.
And then again, if you want to quit that, you have to press Q, just like you had to exit the man pages. There are a couple other commands that I'm just going to briefly touch on for viewing files. So the first is head. You could go ahead and run head, and it'll print the first 10 or so lines of the file from the top. So this is Python has a head command, R has a head command. They all do the same thing. They just print X number of lines at the top of the file. And then similarly, if you want to see some number of lines at the bottom of the file, you use the tail command. And it'll just give you the bottom of the file. I think the last 10 is the default. And there are a bunch of arguments and flags that you could pass to all of these commands. Less is particularly helpful because like if you have like separated values like CSV files, Excel files, tab separated files, you could use less to view them. And there are arguments that you could pass to less that actually separate the columns so that in your terminal, you could actually look at your CSV as you would see it in Excel. And then you could also customize like how many rows or head and tail print. If you want a certain number of rows on either side of that, you could customize that as well. So all of that, again, if you're interested in it, you could look at the manual pages and get a sense of what the flags are. Okay, so now we'll do some more manipulations of our files. So one really helpful command is the copy command. You often want to copy files to different places. And so copy, does anybody want to stab a guess at what the copy, the command for copy would be? CP. Just take the first two consonants, copy. So CP. So let's go ahead and copy our animals.txt file. CP. So the first argument that we're going to pass is the name of the file that we want to copy. And then now we have to also pass the name of the copied file, right? So animals copy.txt, for example. Does that make sense to everybody? So the first argument here is the file that we're copying. And then the second argument is the name of the newly copied file. The reason we have to do this is because we're copying it to the same directory in this case. So if you were to copy animals.txt to animals.txt, it would actually just not do anything. It would sort of overwrite the current version of animals.txt and nothing would have changed. So because it's in the same directory, we have to give it a different name.
And again, you can add -v to make sure you're copying things to where you expect them to be copied. But
Let's
again, totally optional.
do it. And another thing here is, like, in this case, we're passing both flags, optional flags, and arguments to this command. The flags are coming before the arguments. If I was to put -v at the end, I'm not sure it would work. Yeah. So if we do that, we see that it prints to the terminal animals.txt copied to animals copy.txt. And so if we list the files, we see that we actually now have both of those. I misspelt animals in my copied file, but that's okay. We could actually fix that pretty easily with a command that we're going to talk about in a second. But we're not limited to copying files into the current directory, right? We could also copy them into another directory if we wanted to. So let's go ahead again and copy animals. This time we're gonna copy it from here directly into the text files folder. So copy, so CP animals, yeah. And then, so we have to give the name of the directory that we're trying to copy this into. And then again, the name of that file, which we'll call animals copy.txt. That's true. I'm doing this for a very specific reason that I'll illustrate with a different command in a bit. But you're right. Because it's going to a different folder, you don't have to change the name because it's not going to be overwriting anything. So we could do that. And then let's list the files in text files by passing the directory name to the ls command. And we'll see that animals copy is now in there. Let's, I'm going to skip ahead. So if we wanted to, we could move files around without copying them. For example, maybe you don't actually want to copy the whole file. Maybe you just want to move it somewhere. We could do that with the mv command for move. And then just give the name of the file. Animals.txt. And the only other argument that you have to pass to it is where you want it to go. So we want to move animals.txt into the text files directory. So we just give it the text files folder name. We don't have to specify anything else because we're just moving the file. So we're not renaming it or anything. So we're just going to pass the name of the directory. And when you do that, you'll see that animals.txt is no longer in this directory. But if I view the contents of text files, we now have both animals.txt and animalscopy.txt in there. Cool. And then Another really useful feature of the move command is that not only does it enable you to move files elsewhere, it's also the same command that you would use to rename files if you wanted to. So for example, I could rename my animal copy.txt to animals copy. What we're actually going to do though is we're going to move the animals copy.txt into text files. But remember, because you already have a file in text files called animals copy, this would actually just overwrite that file. In this case, we actually don't really care about animals.txt, so who cares if we overwrite it? But like if this was data and you were moving a data file from this folder to that folder, and there's a file in that folder that shares the same name, it'll immediately overwrite it and not warn you. So again, just be careful. As long as you're not careless, you should be totally fine. And so upon moving it, we're also going to rename it simultaneously by just giving it a different name. So animals copy2.txt. And this, by renaming it simultaneously while moving it, we're ensuring that we're not overwriting any file in there that shares the same name. You could confirm this in other ways by viewing the contents of that folder. And so we could do that. So now if I list the contents of scripts, I see there's 3 files there. There's the original animals, there's the copy that we made and then moved, and then there's the copy that we made and then moved and renamed. So there's all 3 of those. And this is where I'm going to take a minute to illustrate some really useful features. Like we're only dealing with a few files here, but what if you have a directory with just like tons and tons of files that share, that they're all different, but like maybe they share some features to their naming. Like maybe they all contain certain keywords and you want to move like, let's say 100 files from one directory to another. You know, in your GUI, you would like highlight all of them with your mouse and then drag them, right? You could basically do the equivalent of that in your terminal by using what are called wildcards. Wildcards are meant to, they're basically meant to replace certain strings of text in file names and just make accessing certain files a lot easier. So for example, we have these 2, and in the lesson materials, by the way, I list the wildcards. I'm only going to talk about one of them, the one that I think is most common, which is the asterisk. And so I'll illustrate it by way of example. So we have these 2 copies of animals.txt. We don't actually need these copies. So let's say we wanted to simultaneously get rid of both of these copies without having to remove one and then remove the other. Well, the way that we could do that is we talked earlier about the rm command, the remove command. And so we could remove any file that contains the word copy by doing something like this. So what this is saying is this asterisk here is saying any characters. Basically this, we want to find the word copy and it can be preceded by any number of any characters and followed by any number of any characters. So the wildcard is literally a replacement for anything in a sense in the name of this file. So because there are only 2 files in our current directory that match that criteria, right? We have animals copy and then we have animals copy 2, right? So the asterisk is basically replacing everything that comes before and after copy. Does that make sense? Yeah, if I had run that, it wouldn't work because I wasn't in the right directory and there was no files that share that. But again, we could just access those files by passing the directory. So if we do this, we'll notice that if we ls text files, those files are now gone. So it simultaneously deleted both of them. We could also illustrate this in a different way. Let's just go ahead and cd into the scripts folder. We have 2 files here, 2 Python scripts. So we have hello world.py and we have some useful script.py. Let's say we didn't want them to be included in the scripts folder for some reason. Let's say we actually wanted to move both of these files simultaneously to the previous directory. So to intro bash demo, we want to get them out of scripts. So we could do that using the move command. And what we're moving is anything that ends in .py. So regardless of what the name of that script is, if it ends with .py, so if it has the .py extension, it's going to be flagged by this command and it's going to be moved where we tell it to. And does anybody remember how we tell bash that we want to go back one directory? ... So we could just pass ... as the directory that we're sending it to, and it'll move those two files back one directory. And if you want to see that, you could cd to the previous directory and see them. Does that make sense? I actually don't want to have these scripts here because they're scripts. They should be in the scripts folder. So I'm going to go ahead and just move them back into scripts using the same logic, right? Move anything that ends with .py into the scripts folder. Cool? All right. So in the lesson notes that you guys have access to, there's a summary of all of the commands that we've used and what they do and some of the flags. You guys could look at that if you need a refresher, but we're going to go ahead and start doing the fun stuff. So these are all of the basic commands. Like you could now, if you wanted to, more or less navigate your entire computer, move things around, copy things, just using the terminal. So you could already stop using the GUIs, which is exciting. But now we're going to start doing some stuff that's a little bit more powerful and I think better highlights like the power of working in an environment like Bash, stuff that you probably wouldn't even be able to do very effectively in the GUI, like My Documents or Finder or whatever. So the first thing we're going to do is we're actually going to go into text files. So change directory into text files. Because we're going to work primarily with this animals.txt file that we've generated, or that we have. So we have this huge file that has a bunch of animals. What if we wanted to only look at the animals that have fish in their name from inside this text file? One way to do that would be to open up this file in Word, Control F for fish, and then count all of the instances of the word fish. It would actually tell you how many instances are in the file. So that's one way to do it. Alternatively, we could use this really cool tool. There's a few different tools that you would be able to do this with, but we're going to use the common one. It's called grep. And you might have heard that word before. It's used in other languages too. It's not unique to the command line. But grep stands for Global Regular Expression Print. And if you don't know what regular expressions are, I'll briefly touch on them in a bit. But grep, let's actually just look at the man page for grep first. If you're in Git Bash, that would be grep --help. So the grep utility searches any given input file, selecting lines that match one or more patterns, right? So from that, we know that we're going to have to give grep some file that we want to search and then some criteria to search for, right? So that's how we're going to use it to identify all of the fish in animals.txt. And then grep is incredibly powerful. It's got a ton of flags that you could pass to it. So we could do this by doing grep, and then we have to give grep the search pattern in quotes, right? So we'll use single quotes, fish. I think you could use double quotes too, right? You can use double quotes. They're often interchangeable.
Bash is a little more specific about them, but use it for more.
Yeah. Yeah.
You have to use the quotes.
Yeah.
Mm-hmm.
It might work it up.
Are you sure? Because I didn't.
Yeah.
Oh, you don't have to?
Generally not, but the thing is when you add in actual regex patterns, they often have symbols that are interpreted in Bash differently, like wildcards.
In fact, we'll see one in a minute. That might not work.
So it's best to always use the quotes to be sure.
Yeah.
Is like the star has not a totally different meaning, but like you're using it for a totally different purpose, putting it in the pattern versus like for Bash. Yeah.
So grep fish. So we're going to search for the all instances of the word fish. We have to tell grep where we want to look for fish, right? Well, we want to look for fish in our animals.txt file. So when we press enter on this, it's going to scan through animals.txt and pull out all lines where the word fish occurs. Right? Super fast. And by the way, it would be just as fast if this file was like 1 million lines long. It's incredible how speedy that is. Your word processor would probably crash if you had a file that was 1 million lines long and you were looking for all instances of a particular thing. So that's the beauty of the terminal. Cool. So that's cool. But by default, it's important to know that a lot of command line utilities, especially the ones that come natively, will actually just print their outputs to the terminal, right? Like it just printed all of the fish here. It didn't save them anywhere, right? But what if we wanted a separate file that has all of the fish? What if we wanted to create a file that's fish.txt? Now, we're using fish as an example here, but what if you had whole transcriptome data and you had a bunch of things that were transcription factors and you wanted to create a separate file that includes only the transcription factors? What you could do is you could grep for anything that's in the that has the words transcription factor in the FASTA headers and just zip them to another file in 2 seconds. Okay, so the way that we do this is we use what are called bash redirects. So we use the same command, so grep fish animals. Now we have to tell bash that we don't want the output to be printed to the terminal. We want to send it to a different file. And we do that using the greater than symbol. And intuitively, I mean, this symbol kind of makes sense to me. It's like, take this input and just like send it. It's kind of like an arrow, right? Like send it to this file. But what file? We have to tell it what we want this file to be called. So fish.txt. Makes sense, right? But when you press enter on this, you'll notice nothing gets printed, right? But if you do an ls, we now have this new file, fish.txt, and we could view the contents of that file. How could we view it? What should we use? What command? Not print. That's in Python, and that just prints specific things. How do we view the contents of a text file on the command line?
I'll send you away. Then?
I mean, I love that answer. You absolutely could use Vim. We're not going to. We'll use Vim in a bit, not for this. We could use cat. This file is small enough that cat will actually just print it there. Remember, if this was super long, we'd want to use something like less, maybe head, tail, something like that. What if we wanted to? What if we didn't want to create a separate file with all of the fish? But what if we just wanted to know how many times the word fish occurs in animal.txt, right? That's a little bit different. Maybe you just want to know how many transcription factors you have in your FASTA file. You don't actually want to create a separate file with them. Well, we could do that by passing the same command. So grep fish animals.txt. And instead of sending the output of this to a different file, we're going to pipe it. For those of you who were here for the R tutorial, this works in very much the same way as the dplyr pipe, right? So what it's going to do is it's going to take the output of this first command, the grep fish animals, and use it as input to the next command that we give it. And because we're counting, we're going to use a command called word count. So WC. And the WC command has a bunch of flags that you could pass to it, one of which is L, which just tells it to count lines. So don't count words, but count lines in the file. So because grep outputs a single line for all the fish, right? It just pulls the lines where the word fish occurs. We could pipe that to the WC flag L, and it'll just count all of the lines. And so when we do this, it tells us there's 20 occurrences of the word fish in animals.txt. So does that make sense, this idea of pipes, using the output of one command as the input of another? You could chain these together and create like really complicated bash commands if you want to, and actually get quite a lot done with very few commands, depending on what you're trying to do, which is really cool. So, oh, cool. I already did the redirect. I meant to do that now, but I already did it. Sweet. So what if we wanted to, so this is going to be one of the more complicated commands that we're going to run today, but we're going to do it. So in our current directory, we have animals.txt, we have fish.txt, which contains all the fish. What if to fish.txt, we wanted to add all of the animals that start with the letter E, and then simultaneously rename the file to fish plus e.txt. But we don't want to overwrite the file. We just want to add the animals that start with E to the end of fish.txt. Well, you could do that in Bash as well. So the way that this is going to work, we're still using grep, right? So we're still looking for occurrences of a particular pattern in this file. Now, previously we just typed fish, right? Because we were looking for all fish. Now what we want is all things that start with specifically the letter E. So grep actually allows you to use really complicated search patterns with what are called regular expressions. Regular expressions allow you to provide, they use sort of syntax and a bunch of different symbols to target very specific occurrences of strings or characters or words or letters, whatever, in a bunch of different text. So you could basically, regardless of how complicated the text is, you could pull out instances of very specific patterns using regular expressions. And these things could get like really large and complicated. But basically all we're trying to do is identify animals that start with the letter E. So we could do that by telling grep that we want to start at the beginning of every line. And you do that with the, I don't even know what that symbol's called, the hat, the circumflex. Sorry? Is that what it's called? Amazing. Okay. Using the circumflex. So this symbol is regular expression for start at the beginning of the string. Because otherwise, if we just put E, it's going to find all instances, all lines that contain the character E anywhere in them. But we want things that start with E. So we have to tell it that we want to start at the beginning of the string. And then you put E. And then that's it. It is case sensitive. And then animals. Before we do anything, let's just go ahead and print that. Let's make sure that this is doing what we want it to. It is. That's nice. So I didn't include this in the lessons, but I just thought of it. If you want to rerun a previous command or maybe add something to a previous command, use the up arrow keys. So just use the up arrow key and just cycle. Right? So we know we want to use, we're going to reuse this command, so you can just cycle to it using the up arrow keys. And so now we want to add this to fish.txt, but we don't want to overwrite. So we call this an append, right? We want to append these results to the end of fish.txt. And you do that not with one greater than sign, but with two. So this will append to that file. And we give it fish.txt. Don't run that yet. Did you run it? Doesn't matter. Well, you'll append twice. Because I want to just briefly touch on, remember I said we want to simultaneously rename this thing? Because now it doesn't contain only fish. It also contains the animals that start with E. And so you could do that by just stringing commands together with the and sign, the ampersand, I should say. And in this case, we're passing two of them. So passing these will basically, whatever follows this will only run if the previous command succeeds. Right? So if this works without producing any errors, then it's going to run what we tell it to run next, which is going to be renaming the file. There are also a bunch of, there are some other commands or sort of controls that you could use that will only run it if the previous commands fail. You could use these types of things to run processes in the background. For example, maybe you want to run something on one processor and then run something else on a different processor. There are command line operators that you could use to tell Bash to do that. You could also split them on separate lines using semicolons. Like, you do have a lot of power in stringing commands together using pipes, redirects, operators like ampersigns or ampersands. But now we basically want to, after this command works, so after it appends all of this to fish.txt, we want to rename fish.txt to fish plus e.txt. Yes. it's supposed to be move.
We're renaming the file. If you wanted to keep fish.txt and also have your appended file,
Then you wouldn't have to do this. Right? Like if you didn't want to, I could also just like get rid of all of this and just run the move command after the fact if I wanted to. Like I don't have to string these together in the same line. I'm only doing it really to show you that the terminal has all of these cool operators that allow you to string commands together in different ways. And when you're writing like bash scripts, for example, some of this can be pretty cool.
It's just a bit something missing. Our new screen is chopped off, but it says fish.txt and then it's like a space fish plus.
I gave it what I want to rename the file to. So fish_plus_e.txt.
The window itself is
Can you
kind
shrink the
of,
window a little bit?
yeah, maybe
Because there's
it's
like a character to cut off.
make the window a little smaller.
Other side too. Is that, can you see that?
Yes.
Okay, yeah.
So it's overflowing, but it's still being interpreted.
Okay.
but like the move command doesn't have a, like doesn't have, you don't have to move it to a different directory to rename it. You can just rename it within that one directory. We didn't really cover that one, which is probably why there was some confusion.
Oh, I see. Yeah, like we're just renaming the file in place, right? In the directory that it's in. We're not moving it to a different directory.
Kind
Yeah.
of wacky, but that is how you need bash. You just kind of move it to itself with a different name.
Yeah. Cool.
If you wanted to also include all the animals that start with R, could you just put that beside the E, or do you have to?
You have to, that's a good question. So in regular expressions, you would separate those with the bash pipe symbol.
Okay.
And this is why it gets tricky, because the pipe symbol in regular expression doesn't mean use the output as input. It means or. So we're saying in this case, if I did something like this, it would be give me all of the animals that start with E or start with R. Does that make sense? And then, yeah, the rest would be the same, but that's the basic idea. So regular expressions could be very complicated if you want them to. And you could use wildcards and stuff like that in them as well. Okay, so with that out of the way, let's go ahead and actually run some commands or some scripts, some programs. So let's go back one directory and simultaneously move into our scripts folder where we have our Python scripts. So we could do that in this way, right? Changing directories, back one, and then into scripts. So now if you list the files, you have these scripts. So if you have Python installed on your computer, you'll be able to run the Python scripts. If you have bash installed on your computer, which obviously you do, you'll be able to run the bash script that's in here. But maybe you first want to confirm whether or not you actually have these programs installed before you try to run them. You could do that using the which command. So if you type out which Python, hit enter, it'll print out the full path to the Python executable file or binary that is used to run Python scripts. And when you open up a Python interpreter in, Jupyter or PyCharm or like any of these different things that run Python, it's essentially using this to run that code when you execute it. It's using this binary that's located in your computer, which in my case here for Python 3 is in the Anaconda directory because I installed Anaconda. But my installation of, for example, Python 2 is actually in this completely different directory, library frameworks, Python framework, in a completely different place on my computer. So the which command basically allows you to confirm whether you have something installed. If it's not installed, it'll just print nothing. If it is installed, it'll tell you where on your computer that particular file is located that's being used to run these programs. And you could do this with any of the commands that we've run, right? So like which ls. ls is just a command that's doing stuff. It has to be coming from somewhere. So if you use which ls, it's telling you that it's using the ls binary that's in like the root of your computer and in the bin folder. which is binary. This is where like all of your binaries are stored. And it's a folder that like by and large you'll never go peek in, but you could if you wanted to. So now that we have confirmed that we have Python installed, let's use Python to run a Python script. So let's run the print hello world thing that we used less to view earlier. So the way that you do this is you just type Python and then the name of the script that you want to run. In our case is hello world.py. Do it. And it prints hello world to the screen. Pretty straightforward. So regardless of how complicated this script is, it would run, right? Because remember, scripts are just text files. So for example, what if we wanted to run the bash script that we have in here? Well, let's first look at the bash script to see what it looks like. So less.
So the git bash users in the room, type in Python, you get there. Okay, yeah. So git bash, we'll talk about how to fix this later today with a thing called paths. But basically, bash is looking for Python in that folder that James' instance is being showed by which. But git bash, since it's newly installed and hasn't been quote unquote linked yet, doesn't know where to look. So we'll look into fixing that.
So when you typed in which Python, it printed nothing, right?
It probably printed a long list of folders.
Yeah.
And what those folders are is where it's looking for something called Python. So in James's case, it just found that in one of the folders and printed out where it found it. If it didn't find it, it's like, hey, here's where I looked. I didn't find it.
Yeah.
But
we'll talk in a minute about why that happened.
And how to fix it.
So let's look at this shell script. You'll be able to run this one. So this is what it looks like. This script will print numbers from 1 to 100 in, and then it counts down from 3 to 1, and then it prints all of the numbers from 1 to 100 with a brief pause in between. It's like this super simple script that I wrote yesterday. It's just to convince you, again, that scripts are just text files. Like this is just a text file that was written using bash syntax so that when I use the bash command to run it, it knows how to interpret it, it understands the instructions, and it does what the script is supposed to. So the way that you run a bash script is type bash and then the name of the script. And then you run it. 3, 2, 1. Da, 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 da. So just take a minute and like think about your own work, right? Like you could write an R script, which by the way, you could execute using the command R script. You can't see that because it's all the way at the bottom, but which R script, right? So you have a binary to run R scripts. It's installed with R. You could have a script that takes a bunch of data sets, merges them together, uses dplyr and the tidyverse to create summary data sets, then uses ggplot to create figures, and then automatically writes those figures to particular directories. And you could do all of that by just writing the script and then executing it from the command line. Now you might be thinking, oh, well, why would I want to do that when I could just do it in RStudio and like do it interactively? Well, if you're doing it on a server, you might not have RStudio, right? And maybe your data files are so large that you can't put them on your local computer and work with them because it takes up all of the memory or you don't have enough storage. So just the idea of like being able to write scripts to do the things that you want to do, execute them from the command line, and be confident that the output is still going to be the same that you would get if you were just doing it in RStudio. Again, because it's just a series of instructions that so long as you have the program to run it, the computer knows how to handle and understand. And so for the last few minutes, I'm just going to talk briefly about paths and configurations and stuff like that. So by default, the shell has in the same way that you could like define variables in Python and R, you could define variables in Bash. Bash actually has a bunch of what are called environment variables that alter the behavior of the shell in some way. And what I mean by behavior is like where to look for particular files. Like it didn't know where to look for Python, so it just spewed out where it looked and it didn't find it. And so I'm going to introduce you to two specific environment variables. The first is the path variable, and the second is the Python path variable. So the first, if you want to just look at the path variable, the way that you could do that is using the echo command. Echo is like the Python equivalent of print, or the R equivalent of print, or like basically the equivalent of print in every other language. And then variables to be accessed in Bash have to be preceded by a $sign. And then environment variables are capitalized like this. So we're trying to access the variable path. So if you press enter on that, it just spews out a bunch of directories. And it's hard to tell. These directories are separated by colons. So let's actually take this one step further and print each of those directories on a separate line just to make it easier for our eyes to see. So we could do that. So that would be the input. How do we tell it to use this output as the input for something else? Does anybody remember? Yeah, vertical bar. So we're going to pipe the output of path to this command called translate characters. So TR. And there's a bunch of different ways to do this kind of thing. This is like quick and dirty method. So we want to replace everything that's a colon in the output of path, because it's the colon that is separating the directories. And we want to replace it, and mind the quotes. You need to surround that by quotes. And we want to replace it with new line characters. So new line, this is universally going to be interpreted as start a new line. So instead of separating the directories with a colon, it's going to separate them with a new line, which means it's going to put the next thing on another line and then sort of just do that. And when you press enter, all of the directories that it's searching are now in a separate line. So you could actually scan through here. So each of these directories is where Bash is going to look for things that are installed on your computer. So when you type in Python, it's going to look in all of these folders to make sure that you have a binary called Python. So if you've ever installed a program that needed to be used on the command line, for example, and the program didn't work, it's probably because it is installed, but the computer just doesn't know where to find it. And so you have to tell the computer where to find it. And because path is just a variable, you could add directories to your path permanently, so that if you have a particular folder where you add installed programs, maybe like a downloads folder or something, or like some other folder in your home directory, you could add that permanently to path. And then it'll always look in that folder for programs that you've installed. 95% of the time when I've encountered folks who have installed things that are not working, it's just because the computer doesn't know where to look for it. And it's usually a super easy fix. Does that make sense? So I'll show you briefly in a minute how you could actually permanently modify the path if you needed to. But I just want to make you aware that the path exists, that this is what your computer uses to search for stuff that's installed. And if something's not working, it's probably because it's not in the computer's path. And in a very similar way, you have this other variable called Python path, which can also be permanently modified. Python path is a little bit different in that these are all of the directories where Python is going to look for modules that have been installed. Does that make sense? So whereas path is all of the directories where Bash looks for utilities and commands that have been installed, Python path is the directory where Python is searching for modules that have been installed. And so all of the Python modules that, for example, get distributed with Python are included here. Yeah.
Yeah, I got a blank one.
You guys all got blank ones?
Yeah.
Probably because you all downloaded Anaconda. So Anaconda doesn't use the Python path. Anaconda has its own separate directory where all of the modules are stored in a self-contained environment, so it doesn't need this, which is helpful in a lot of ways because it creates this self-contained environment. The difference with me is that my first installation of Python, I installed Python onto my computer through the terminal system-wide. And so it installed this directory in the root of my computer where all of the modules go. And then it created the Python path environment variable so that Bash knows where Python is and Python knows where the modules are. But just to make you aware that depending on how you install it, you might have these environment variables. And there's a host of other environment variables that tell specific programs on your computer where to search for the things that they need. So if things aren't working, it might have something to do with paths. Finally, we'll talk about configuration and why my terminal looks a little different than yours. So let's actually, everybody, let's go. We're done with this directory. Let's actually go to our home directory. Remember, we could zip straight to our home directory by changing directory using the tilde. So let's list all of the files in this directory. So scanning through here, I'm looking for this particular hidden file, .bash_profile. Do you guys have this? You do? Does anybody have a file that's called .bashrc? Okay, cool. So we're only going to work with the bash profile. There's slight differences between a bash profile and a bashrc file. But for our purposes, we could assume they're the same and we'll just use the bash profile. So this is a configuration file that sets up all of the customizations and configurations that get loaded into bash when you open your terminal. So when you open your terminal, this file gets run sort of top to bottom, and then all of those customizations get loaded in with it so that they're available to your terminal session when the command prompt appears. And so do less .bash profile and just look at it and tell me what you see. So if you view the file, what do you guys see? Not much?
Contents added by
When it was added.
Contents added by Anaconda. So Anaconda automatically modifies your .bash profile.
And again, get bash folks, if you don't have a bash history, we're gonna
Bash profile.
yeah, bash profile. Yeah.
So let's edit this file. Let's like add something in there. So again, I'm gonna open mine up. We're gonna do this in a program called Vim. Yeah. No, if you're comfortable with Nano, do Nano. I'm not comfortable with Nano, so I'm gonna teach Vim.
We had a drunk argument about Vim versus Nano.
That's fair.
It was really
right.
So the thing about Nano is that it's not installed by default on Windows machines. That's it. So Vim is a text editor like Notepad, for example, but you can consider that it's that, but on steroids. And it's installed by default on any Unix-based machine, so on Linux servers and clusters, on Mac machines, but also in Git Bash. So it's a text editor that you could use to create, edit, modify files in any way, and then save them, kind of like you would save a document in Word, but you're doing it from the terminal. So we're going to do that. The command to use it is vi, and then you pass the name of the file that you want to open and start editing. So in our case, it's .bash profile.
And if you don't have one, like a bash profile, it's still on this command. It will make the file.
Exactly. This will automatically create the file if it doesn't exist. So you run that. And so this is mine. You could see there's a bunch of lines of different things here. And this is why my terminal looks so different than everybody's, because I'm customizing the color and the way the prompt looks and all of that. Everybody got this? Yeah. So yeah, your file's not going to look like this. So try like typing ASD like. Well, no, I was gonna make that point. I was gonna illustrate the fact that you can't.
You said press A, which also puts your answer.
I know. I just realized that when I pressed it.
That's why I was like, okay.
So by default, you can't just open Vim and then start typing stuff. You actually have to enter insert mode, right? You have to tell Vim that you want to start writing stuff. Otherwise, you're in like navigation mode. And there's a bunch of hotkeys that allow you to like skip through files and do all of this fancy stuff. And Ahmed is excitedly going to give us a Vim tutorial one day because he breathes Vim. Yeah. So you have to tell it that you want to enter insert mode. And you can do that by pressing I or A. And at the very bottom, it'll tell you that you're in insert mode. So now you could type stuff. right?
It's basically like Notepad.
And so the only thing I'm going to show you guys how to customize right now is to create what are called aliases. Aliases are shorthands for commands that you commonly use. So a really good alias that I have, for example, and you could create this by typing alias equals, no spaces. Oh no, I did that wrong. Alias space. I was looking at export. Yeah, anyways. And then the name of the alias. So the name of the alias is what you would type at the command line to use this command. So you give it a custom name. Don't name it something that already exists. Like I'm not going to create an alias called cat because cat is a command that you would run on the command line. So in this case, I'm going to create the alias LL. Equals. This is where the equals comes in. And then in quotes, what you want the command associated with this alias to be. So for example, maybe you want LL to be list all with details in human readable format and then sorted by size. For example, right? And then end quote. Can you guys see that? So basically, capital S. So what we're doing is we're mapping this whole thing to this command, right? So that when we type LL on the command line, it's effectively going to be typing LSALHS. Does that make sense? So let's go ahead and leave that there. I'm going to delete it from mine because I already have it in there. And then press escape to get out of insert mode. And then, don't fight me on this, but to quit Vim, press :WQ. Well, WQ is write and then quit. So you're writing to the file and then quitting and auto-saving. Yeah, so like literally colon, you have to put a colon. So shift semicolon WQ.
And you'll see it show up in the bottom left of your screen.
You can see it here.
Oh, yeah. There it goes.
And then press enter.
No, I just press W. Make sure it's WQ.
It's a WQ, not an editor command.
What? Was it lowercase?
No, I put it in. I didn't put it in lowercase.
Yeah, that's what lowercase.
Okay, so I
Did that work for other people? You have to press escape. See, now you're not in insert mode. Press escape, and now you could go :WQ.
Make sure the W and Q are lowercase.
Oh, that was.
Maybe you accidentally re-entered insert mode and didn't realize it. So now use less on your .bash profile, and you should see that. You should see it there. That command should be in your .bash profile, that alias. Now try, is it there? Now try to run it. Press LL. It worked for me, obviously, but it won't work for you. What? Okay.
LSL is a default alias.
Okay, so if you're on Git Bash, then it worked. If you're not on Git Bash, it didn't work. And the reason is because your terminal is already loaded. Remember, I mentioned that this file gets loaded before your terminal kind of opens. So we actually have to like reactivate this file to load the new configurations that we've added. And you could do that using the source command. So source.
When we get back to it, we'll notice that when we print it out, you'll notice it's not sorted by size and the file letters aren't in format, which are additional options we gave it. So like the new thing you added in hasn't.
Okay, so press source. Yeah, so type source and then .bash profile. Do that. S command not found. That's my fault. And then now do LL.
Can you have it such that the source bash profile runs at the beginning of your bash profile? So that it will always.
So every time whenever you open your terminal, it automatically does that.
Yeah.
It's just because we had our terminal already open, we had to source it. But you could have like restarted your terminal, for example, and it would have done it. Did that work for everybody? No? Did you source it? Did it return errors when you sourced it?
Let's go back to,
Oh, okay.
Oh, that's the issue. The issue is that it has to be on its own line. You have it on a line that has a comment, so none of that gets run.
Oh,
So it has to
okay.
be on a separate line.
Okay, got it.
And so
Oh, perfect.
cool. So the I'm just gonna show you guys one quick thing. Well, I'll do it with less. So this is, so see all these instances of path. Path equals this, path equals that, export path. So what I'm basically doing is I'm adding this directory here to path, and then I'm telling it to export it to the path variable. So this is how you permanently add directories to your path so that your terminal or your shell knows where to find programs you've installed. You just add those directories into your .bash profile and then export it to path. And because this file gets loaded when you open up your shell, it's automatically appended to the path variable and available system-wide by the shell. And you could also do this by, for Python path and stuff like that. You could see I've created like a bunch of aliases. There's stuff that you could look, like I have aliases to move into very specific directories on my computer, like projects that I'm working on and whatnot, so that I don't have to like use the full path to get there every time. A really helpful one, like custom functions or whatever. This is some stuff by Conda. Where's, oh, here. PS1. So PS1 is the reason, I don't remember what PS stands for. Do you?
From something. Not literally something. Just I forget.
Yeah. Yeah. Anyways, there's a few PS variables. PS1, all of this stuff is telling the terminal how my command prompt should look. And so that's the reason I have colored folders and I have like different colored files, and then all my stuff is like green and has all of these colors. All of that configuration is done by just modifying variables that are intrinsic to Bash, like PS1.
Prompt string one.
Prompt string one, which is the command prompt. And then something that really excites me is this parse git branch thing here, which if you come to the next lesson, hopefully will excite you too. But like, if I was to go into a Git repository, it would also tell me where in that Git repository I am, like in my command prompt. And it's super sweet. But yeah, that's all I have. So hopefully you guys feel relatively comfortable in the Bash shell now, and that you could start using it and slowly moving away from like the GUI that you've been trained to use your entire lives. Obviously, you don't have to spend all your time in here. Like some things are just more efficient in your Finder window and stuff. But again, for a lot of the type of work that we do in the department, knowing this skill is basically essential, because you're going to be working on clusters. You're going to want to run scripts. You're going to have really large data files that you don't store locally. And you also want to be able to work with those really large files very effectively. And that's sort of best done in this type of environment, rather than trying to load everything into R, store it all in memory, crash your computer, you know, that sort of stuff. So yeah, again, feel free to ask any questions. We'll have like more advanced tutorials on some of this stuff downstream if you guys are into it. And then finally, if you guys want to teach workshops, let Ahmed or I know. We'll help you develop them if need be, obviously. And if you have suggestions for workshops, let us know about that as well. And yeah, thanks.
Folks, if you want me to come help you out in adding Python